What we've created really is engineering history.
It looked like it's a very, very difficult project because it has never been done in the world for 600 to 700 kilometers.
It will show to companies of a similar size what can actually be achieved.
Well, there's a quote that reminds me of this project from start to finish, and that is a quote from Emerson which says, "Do not go where the path may lead. Go instead where there is no path and leave a trail."
Everywhere on our planet, wherever crude oil reserves exist, an intricate network of pipelines dominate the landscape. Like arteries in the human body, they carry oil and gas that is essential for the mobility of the human race. Today, hundreds of pipelines run across thousands of miles, connecting entirely different cultures and economies. With the passage of time, these pipelines are getting better and smarter, ferrying large quantities of crude with increasing efficiency. This is the story of a pipeline that will take the world of engineering to new heights and will perhaps open new avenues for the world of oil and gas. Hydrocarbons in the desert district of Barmer, in the state of Rajasthan, remained undiscovered until the 1990s. Although some geological and seismic data indicated that oil and gas could be found, the exploration companies couldn't find economically viable quantities. Cairn had been exploring the southern part of Rajasthan block without much success. But things turned around in 2004, when Cairn's exploration team moved to the northern parts. This was a path-breaking move. It changed the fortunes of not just Cairn, but also its stakeholders and thousands of people around Barmer. A few months later, Cairn discovered crude in the Mangala field. It was the biggest onshore oil discovery in India in the last 20 years. One after another, 25 discoveries were made. Altogether, 4 billion barrels of crude oil have been discovered, out of which 1 billion barrels of crude oil is recoverable, enough to contribute 20% of India's domestic crude production in the coming years. For Cairn's joint venture partner, ONGC, this discovery consolidated an already strong relationship. The downside was that the crude discovered had a waxy consistency and a high pour point, which means that to remain in a flowing state, the crude needs an unusually high temperature of more than 64 degrees centigrade. As the temperature drops, the crude turns into a jelly-like substance and eventually ceases to flow. Cairn was planning to produce 240,000 barrels of oil per day in the years to come. The nature of the Barmer crude demanded special extraction facilities, as well as sophisticated refineries. But the oil fields were hundreds of kilometers from the refineries, so the challenge was to take the crude to the buyers.
About 3.5, 4 years ago, we realized that the quality of the crude was such that it was going to be difficult to transport it. It was going to require a fairly specialized technology, a very unique technology to transport it. And we also realized that the government nominees were unable to construct the pipeline. So we then, in conjunction with the government, through a fairly extensive consultative process, agreed to build the pipeline. And this was the best way and the fastest way really to start producing the crude and to take it to market.
The pipeline that Cairn decided to build was by no means an ordinary steel pipeline transporting crude oil. The proposed pipeline would need to maintain the temperature of the crude oil above 64 degrees centigrade to allow it to flow. Before the Rajasthan discoveries, Cairn was primarily an upstream company that had focused on exploration and built development expertise in South Asia. It had no prior experience in making pipelines on a very large scale, especially pipelines that were required to traverse plains, deserts, and a number of canals and rivers. The challenge was to map out the shortest possible route that would ensure maximum points of sale, minimum damage to the environment, and minimum interference with livelihoods of people during the laying of the pipeline.
The pipeline would enter Gujarat state from this area, which is near village of Dua, and then travel southward.
While the technical team was trying to zero in on the most appropriate technology, a dedicated team was trying to figure out the best route.
Avoiding the big cities of Patan, etc., via village
The
Tharad.
proposal to shift the point of delivery from Barmer to Bhogath on the Gujarat coast was sent to the Government of India.
That would be the proposed route of pipeline.
The initial proposal for the shortest route would have run through the Gulf of Kutch in Gujarat. The Gulf of Kutch is a fragile ecosystem and home to several marine and avian species. Even though it added 75 kilometers to an already ambitious pipeline, Cairn altered the route in order to preserve the environment.
The environmental issues are quite significant on a project of this scale. But we have a specified route which we've studied long before we put anyone on the ground to do any work. And that route takes into consideration environmental sensitive areas. We have to do an environmental impact study and a social impact study. So we have to be mindful of communities, water sources, cultural relics or religious temples or any other religious site. So that's all taken into consideration when we select the route.
The total length of the pipeline was now nearly 700 kilometers. From Barmer to Bhogath, the pipeline would have to negotiate hundreds of crossings. By the first quarter of 2007, the technical team at Cairn had solved the issue of how to keep the oil flowing. All the major concerns about the sale of the crude, preservation of the environment, and the success of the technology had been addressed and sorted out.
Cable inside which basically heats the pipeline and keeps the oil flowing.
If we were to pump the Rajasthan crude into a regular steel pipeline without insulation and without any heating system, very quickly the crude would cool down. And as it cooled down, it would become harder and harder to pump. And actually, within 200 or 300 kilometers, it would start to solidify and you couldn't pump it at all.
The answer emerged in a technology known as Skin Effect Heat Management System, or SEMS. The 700 kilometers long pipeline was to be laid 1 meter under the ground. 2 sets of pipes were to be laid next to each other. The larger 24-inch pipeline was to carry the crude, and the smaller 8-inch pipeline was to carry natural gas produced in the Rajasthan fields. The larger pipeline was wrapped in 3 layers of insulation. These coatings would not only minimize heat loss, but also protect the pipeline from physical damage. The smaller 8-inch pipeline was going to supply clean natural gas to generators of 1 megawatt each, stationed every 20 kilometers along the length of the pipeline. The generators would pass an electric current of 4,000 volts through a high voltage cable placed within a 1-inch tube. This 1-inch tube was welded to the main pipe carrying the crude oil. An electric current was to run through the cable and then flow back inside the inner walls of the 1-inch tube. In SEMS technology, the 1-inch steel tube, which has a high density, resists the flow of electric current owing to its densely packed molecules. This resistance causes the temperature of the steel tube to rise. Eventually, the temperature of the tube rises to as much as 90 degrees centigrade. This heat then gets transferred to the main carrier pipe through conduction, where the hot oil is already flowing.
In some ways, the SEMS system is the lifeline of the pipeline. In the event that the flow slows down or stops, perhaps in an upset or for operational reasons, the risk is that the pipeline could turn solid and then you would be unable to pump it. But with the heating system, you always have the ability to heat the pipe up and to remelt the crude and to keep it flowing.
We conducted a field trial test of over 1 kilometer of line, and we later on came to know that the results are exactly and even better than the design.
Cairn was now ready to construct the world's longest thermally heated pipeline. A company that was never in the pipeline business was now about to create history in pipeline engineering. Suddenly, the pipeline division in Cairn's office began to buzz with activity. A small team of 7 members quickly grew to over 300.
We've assembled one of the best teams in the world in the pipeline business, and the best brains from all over have come to conceive the pipeline, do all the engineering work.
After months of planning, it was now time to move to the field. The construction process commenced by informing more than 50,000 landowners through whose lands and fields the pipeline would eventually traverse.
तेल की पाइपलाइन केन एनर्जी के द्वारा निकाली जा रही है, उसमें पंचनामा कल सुबह 9 बजे से ग्राम सड़ेसा से शुरू किया जाएगा। सभी सड़ेसा ग्रामवासियों को
Nearly 200 field staff walked the entire stretch of almost 700 kilometers, meticulously maintaining a log of all the properties.
height is 9.5 meter.
This log was later used to provide compensation to the owners. Each landowner was compensated for both his land and crops by a competent authority appointed by government. To create a long-term relationship with the people living along the route of the pipeline, Cairn started a number of community engagement programs. Today, more than 40,000 farmers and their families, along with the local administration, are benefiting through agri-kiosks, SMS-based agri-alerts, health checkups, along with water harvesting and sanitation schemes. Farmers are being taught new and scientific methods of farming. They're also getting a fair price for their produce. Meanwhile at Mundra, the pipes were produced in accordance with strict deadlines. Heavy sheets of steel were rolled into pipes and welded according to stringent specifications. Each pipe produced in this facility went through several quality tests, including X-rays and ultrasonic rays. These pipes were then carefully transported to several different locations throughout the length of the pipeline. Each stage of laying the pipeline was carefully planned and executed. First, the notified areas were marked and cleared of all vegetation. Necessary permissions were sought and compensation for using this land route was paid before the work began. Even though the width of the trench is 2 meters, a 30-meter wide strip was graded and leveled to allow access for machinery. Valuable topsoil was kept to one side so that it could be restored after burying the pipeline. Every effort was made to return all land to the farmer in its near original state. The trenching team then dug a 1-meter wide trench and prepared the ground. A project of this scale and size requires intense discipline, planning, and foresight. But more than anything else, it requires safety and the welfare of its people and those living nearby.
At the end of the day, it's all about people. And people should go home from work just as well as when they arrived at work, so that they are not suffering any harm from the activities that we conduct during the course of our business.
After the pipes were laid end to end, the joints were welded. Stringing and welding are labor-intensive and time-consuming jobs. During summers, the temperatures in Rajasthan can soar to 50 degrees centigrade. The heat generated by activities like welding can further reduce the efficiency of the field crew. Yet, Cairn and its main contractors, Larsen & Toubro and Punj Lloyd, succeeded in adhering to their deadlines. 100 kilometers away, it was not the heat that bothered the crew. At the Luni River crossing, shallow underground water had seeped in and formed an unwanted pond. Moisture is the enemy of any pipeline. Long-term exposure to water can cause rusting and will eventually reduce the life of a pipeline. Sukhri and Luni are among several dry rivers that the pipeline had to cross. Once in every 40 years, there is a likelihood of their flooding, thus wreaking havoc with the pipeline. So here, the pipeline was laid 10 meters under the ground with an additional concrete coating.
There's no water in the river course, but it could be today, it could be tomorrow, and it may never be in this monsoon, but we can't take that chance. So we have to calculate at what the scour level, what was the historical data of the deepest scour level, and then we lay the pipeline 2 meters below that deepest scour level.
A few kilometers downstream, the team at the canal crossing had to tackle another engineering challenge. The pipeline was to run under a canal that is 15 meters deep and 160 meters wide. This canal is a lifeline for thousands of farmers living downstream. With the help of research provided by institutions like the Indian Institute of Technology in Roorkee, 700 such difficult crossings were negotiated. State-of-the-art technologies like micro-tunneling were used to excavate the earth and lay the pipes. After a substantial length of the pipe had been welded, tested, and approved, it was laid in the trench. 4 heavy-duty side booms carefully lowered the main 24-inch pipe. The trench was then filled with a layer of soft soil. Then the warning tape and the optical fiber cable were laid. The trench was backfilled and the land was ready to be returned to the farmers. Above-ground installations, or AGIs, built every 20 kilometers all along the route of the pipeline, were also commissioned. The AGIs would supply clean electricity to the SEM system for the entire duration of the project. The pipeline laid, Hari Ram has had his land returned to him. Once again, he has sown wheat. In a few months, when he harvests his crop, thousands of barrels of oil will flow under his farm. At the Mangala oil field, the commissioning team conducted final tests on the pipeline. The entire length of the pipeline was pressurized with water to detect any leakages. After the water had been drained, the pipeline was purged with nitrogen to prevent any internal corrosion. After this, one by one, 4 pigs were sent through the pipeline as a final process of commissioning. The pig train carries a selection of chemicals to clean the pipeline of moisture and any other unwanted foreign material. These chemicals would also prevent any kind of internal corrosion. The moment everyone had been waiting for had finally arrived. With the insertion of the 4th and the last pig, the oil was introduced in the pipeline. What began as a daring idea was now a reality. Cairns' dream of taking the viscous crude to the market had finally taken shape. This is the only pipeline in the world that is insulated and thermally heated all along its entire length of almost 700 kilometers. No other pipeline has an intricate network of 36 AGIs to provide clean electricity to the heating system for the entire lifetime of the project. For Cairn and its partners, all this effort has been more than worthwhile. The pipeline is touching 70% of India's total refinery network and helping to improve the country's energy security.
The project, of course, is truly transformational for the state of Rajasthan because every barrel of oil that we're producing, 20% of the revenues are accruing to the state of Rajasthan in royalty revenues. And for our nation, of course, it's truly a national project because we're now going to be delivering soon over 20% of domestic production, and that's going to have very profound implications in terms of energy security and also in terms of savings.